Yes.
The question that deals with the vertices and regions, for some reason I'm kind of having trouble with that. A network with 8 vertices and 5 regions will have how many edges?
So it's like the Euler's formula, so B plus
We
R.
said Euler.
Sorry. Yeah,
Looks
okay.
like it's Euler, but
Yeah, that's Euler. And it's E plus R, or no, sorry, B plus R equals E plus 2. And then you just plug it in.
Abby, do you want to come up and put that on the board? And
I just tried to draw it and I draw it different.
There's edges in this too.
So vertices plus regions equals edges plus 2. So what are the numbers again?
Oh, okay. So 8 and 5.
So 13 equals B plus 2. B. Does that make sense?
Yeah. Okay, thanks, Abby.
how are you going to remember this formula?
Victor and Ryan eat too.
You could use some kind of a mnemonic, I guess. Yeah, Roy G. Biv or
Victor and
George
Eric.
Eliot's old grandmother wrote a pig home yesterday. Whatever. That's how you spell geography. Typically, students will go, I know it has something to do with vertices and regions and edges, and I think I remember a number 2 in there somewhere. That's kind of where you're at, right?
I'm thinking, I don't know, tell me if this is wrong, but like, whenever you have vertices, there's always gonna be one more, because you have like 2 points and then a segment. So there's always gonna be an extra one vertices, so that's 1. And then with the regions, you're always gonna have to count the one on the outside, the unbounded, I think is what they call it, so that's another one. But I don't know if that's what the plus 2 is, but I'm thinking that's where it's coming from.
Oh, so you're trying to make sense of the whole
The
formula.
yeah.
Okay.
But I don't know.
But why don't you take the simplest closed network we could do? Right? I mean, isn't that the simplest closed network we could? What have we got here? 3 vertices, we've got 3 edges, and we've got 2 regions. The enclosed region, there's always one that we call the unbounded region that's on the outside. There's 2 regions. And you'll notice that vertices plus regions is equal to E plus 2. Or you could say, well, I'm not quite sure if that's it or not. Make another one.
Bless you.
A little house or something. How many regions have we got now? 3. Don't forget the unbounded region. 3. How many vertices? 5.
V,
How many edges?
Do you want a 5 in there or a V?
Yeah. My brain just doesn't. 5. And in edges is what? 6. So, if you knew there's a 2 involved somewhere and you look at these numbers, you're saying, oh, 5 plus 3 is 6 plus 2. Or, you see what I'm saying? You could do 2 or 3 of these and quickly resurrect the formula. Just recreate it.
Okay, so like on the test, will it tell us if the vertices, if like the regions include the unbounded region?
No, there's always an unbounded region.
Okay, and it's always gonna be counted?
It will always be counted.
Okay,
Mhm.
awesome.
So you count the regions that are enclosed,
Mm-hmm,
and then you always put
One
the unbound,
outside.
yep, one outside.
okay.
Okay, good question. All right, did that help you with your second one there?
That did.
All right. Erica's put two questions. She's got one of them answered with this, but the other one came from the skill review test. Who could answer that top one, go to the board and show how to do that one? You want to go take it? And show us how to do that one.
Okay, so let's just say it's a pentagon. So we're gonna make it have 5 sides like this, and then in the center, what it means. So like you can just put a point in the middle, and then this can go out like to all of these things. And since this is 360 degrees, you can just do 360 divided by 45, and it'll give you how many sides there is. So this one obviously isn't right. I think it was 8 actually on the quiz from what I remember doing. So then you would just do 360 divided by 45, and then that would tell you how many sides there were. And so on the quiz it was an 8-sided, because the central angle is always going to be 360, no matter what
All added
polygon
together.
it is. Yes, no matter what polygon it is. So if it was like 60-degree angle, then you would do 360 divided by 60 to get how many sides there is.
And in order to do this problem, you must know that it is a regular polygon, otherwise those central angles could all be different, and it wouldn't, I mean, we couldn't even do this problem. Okay. Any other questions that anybody has from the skills review test? Yeah.
I'm kind of confused on like the exterior angle finding, like if it gives you like the degrees, how to find how many
Sides?
sides there are.
So have you got a problem or one that you could,
Because I know to find like this, the measure of the angle is 360 over n, but I don't know how to like reverse it to find the sides, if that makes sense. So like, let's see, I'll go to the problem that was on the test. So it says, it says, what is the name of the regular polygon that has an exterior angle of 60 degrees?
so if I were to extend this out, this is 60, right? And I don't know, the polygon goes in here and does something like this and is enclosed. It's a regular polygon again, so that means each of these are the same. And what do you know?
That's 360 degrees.
What is?
So, the total angle. So do you just divide 360 and then you divide it by 60 degrees?
Okay, we want to know how many of these 60s will make up that 3, and that gives us what?
8. Or 6, sorry.
6.
It's a hexagon.
So it's got, and then we go with the name. So this is partly testing you on vocabulary, partly on knowing what exterior angles sum is, and so on. Okay.
I have a question on the quiz too.
On the quiz,
Yeah, like on the
Okay.
skills quiz that we
it's called the
took.
skills review test.
The one that asked about 160 degrees, where it gave us the 160 degrees for the inside angle, I don't have it pulled up on my computer right now because it's turning on. So somebody else has that.
So this is a regular
Yeah, it's a
polygon.
regular polygon with an interior angle of 160 degrees, and we wanted to find out how many sides.
Who wants to do it? Who can do it? We've got a regular polygon. Each of the interior angles is 160. How many sides does it have?
Um,
you just do it the opposite way that you did that one?
Do you wanna try it?
Sure. Just tell you?
No, come up here, show us.
I don't know, so I'm just gonna guess, okay? Because couldn't you technically just extend that out? And so then you know that that would be 180, so then this would be a 20-degree angle. And then would you just divide the 20 into 360? And then whatever that math comes out to be.
Well, does it come out to be 18? 18?
Wow.
I made it super complicated.
You did it a different way?
Oh, no, I just got it wrong, and then I went on GeoGebra.
Did anybody do it a different way? Would you like to come show a different way?
So like, I don't know, I kind of did it the same way that we flipped this around. So you have your equation that's like, so we have 160, right? Is that what the end? Okay, so we have 160 equals 180 times, that's an n minus 2, right? And so instead of having the n, we have the answer. I mean, this is a longer way to do it, but this is how I did it.
Now, what's 180 times n minus 2? What's that? Where did you get that?
That's the sum of all of the interior angles. And then you have to divide it by whatever n comes out to be.
I don't know.
Okay, I guess I just have to.
If 180 times n minus 2 is the sum, can you set the sum equal to one of the angles, is what I'm saying.
After you find what n is. I guess that doesn't make sense.
Go ahead.
I don't know how it works, but. And I don't know what that comes out to be. I don't even know if that's a thing. Maybe that doesn't work that way.
I think you're almost there. What did you say you had to do?
Well, you have to find what n is, and then, I don't know, apparently I got.
Why do you need to find what n is?
How many sides there are.
And why do you need that?
Because, that's the answer, you want to get 18.
That's the answer,
Yeah,
okay?
but I did this wrong, I guess.
Erase everything but your top formula. Oh.
Okay.
I think we could solve it this way if we just made a small tweak. Is it Kim?
Yeah, just put an N after the 160.
Why?
It should be 160N. Because what that formula does is solve for the entire sum of the interior angles, and it's a regular polygon, so all the angles are going to be the same.
Originally I was going to do the divided by n, which would be ended up being the same thing.
Oh.
I just didn't have
So-
that on my
oh,
equation yet.
So do that, divided by n, and take the n off the other side. So each one is 360, and this says take the sum and divide by how many there are. That'll tell how big each one is as well. And then we just
That's originally what I
solve
was going to do,
this.
I just didn't put the divided by n on.
Yeah. Now go ahead.
Oh.
So the first step she does is
Streets.
okay. Now what?
And now, I think the easiest thing is to divide both sides by n.
160N, take away 180N is,
More than that. 20.
What's 180 minus 160?
Oh! Okay, I thought it was, I don't know what I was thinking, I was doing a negative 160, okay.
okay,
And then you would do, so you have a negative 120, so you have n equals, and you divide this by negative 20, and then that's 18.
which is the same thing as we got.
Just a lot more drawn out. And
A lot more drawn
A
out.
lot more standard.
How many you like Jeff's method better? Why?
Shorter.
Shorter, didn't require the algebra, the manipulation.
It's also a picture, so I can visualize it and remember it better than.
Okay, so visual helps. Okay. But whatever you're thinking about, that's the way you ought to proceed. Okay. Any more? Yes.
I learned that, but I don't understand the proofs, like, the side, triangle shortcut is used to prove that an angle bisector instruction actually bisects the angle. I don't understand those proofs. I don't know why. It's not understand.
Well, we told you, here's how you construct a angle bisector, for example. How do we know that that is actually an angle bisector? So, the way we did it, we put the point of our compass here and we made an arc right there, right? Then you either change or you leave it the same and you put the point of your compass here and you make an arc right there. Now you don't change, put the same point there and an arc there. Now notice, this length is the same as this length because the arc of a circle has the same radius no matter what. So I can mark this congruent to that length, right? Then I may have changed it or I may not have changed it. Let's say I changed it. This length from here to there is the same as from here to there because I didn't change my compass. I kept it the same width. So this side is the same as this side, correct? Now we drew this in right here using our straight edge, correct? So now if I label this point A, this point B, this point C, and this point D up here, I can say that triangle ABD is congruent to triangle ACD. Can everybody find it? How can I say that?
Because you use the same width of your compass? They must be complete.
How can we say that two triangles are congruent? We can use one of the shortcuts. Well, notice I've got a side, and this side belongs to both of them, so it's congruent to itself. Therefore, I know those two triangles are congruent. Okay? Well, what is the definition of congruent triangles? The definition of congruent triangles says if two triangles are congruent, then what? All three sides are the same. I knew that. That's how I got it. But it also says that all three pairs of corresponding angles are congruent, which means this angle is congruent to that one. This angle is congruent to that one. And this angle is congruent to that one. If I know they are congruent by the SSS shortcut, I know that's true about them because that's the definition of congruent triangles. Well, if that angle is congruent to that, then this line right here must be a bisector, because the definition of a bisector says it's the line that cuts the angle in half. So that's how we use the shortcuts to prove that this really is an angle bisector. Does that make sense?
Yeah, that makes really good sense. Thank you.
That's just one example for the angle bisector. Okay? So not only do the shortcuts help you in measuring trusses before you hoist them up, without doing all 6 parts, they also help us to prove that our constructions really are doing what we say they are. Okay? When we first learned them, we just took it on faith. Here's how you do it. Trust us. Now we can say, if you'll do it this way, you will have angle bisectors because these 2 triangles are congruent, and if they're congruent, their corresponding angles have to be the same size, which means that's an angle bisector. Okay? What else?
Are the central angles and the exterior angles always the same degrees?
Did everybody hear the question? Ask it again.
Are the central angles and the exterior angles always the same degrees? On the quiz, that question, they were. I was just wondering.
Are they always? So they were on the one on the test.
Yeah. Is it because you're making a 360? You have a 360 in the middle and you have a 360 on the inside. Am I thinking right?
They'll always be the
So
same.
what she's saying is, I've got a polygon here. Don't know how many sides it's got, but if I extend this, if it's regular, we're talking regular, right? We don't know how big it is, but this plus this makes 180, right? Always. And these all together make 360, correct? Well, if I come in here and make a central angle, all of these make 360, so does it matter how many sides it's got? Because if all these make 360 and all of these make 360, there's got to be the same number of exterior angles as there are interior, therefore they've got to be the same. Does that make sense? Okay. Great question. Any more? All right, we've got to move along because we've got quite a few things to do. Unit 2 is probably one of the most applicable units we're going to do in geometry. By applicable, I mean real life stuff. So that when you and your, I was going to say husband, but we've got Jeff Harrison. You and your spouse build your own home, and you're getting ready to lay carpet. You're going to go, how much carpet do I need? You'll be able to do a much better job after we get done with this unit. In fact, you'll be able to do a perfect job if you pay attention and get this down. What if you want to put some mopboard? They just ran the carpet up, but frequently people will put what along there? Baseboard, and it could be wooden trim, it could be whatever. And you say, how much of that am I going to need in my room? You're going to go paint the walls. You'll say, how much paint am I going to need? Well, how much will a gallon paint? And you'll read on the side, it will say it covers so many square feet. You go, well, how many square feet do I have in my house that I'm going to paint, in the rooms I'm going to paint? All of these, you're going to build a deck. How big is the deck going to be? Well, how much wood will I have to buy? If I'm going to put a rail around the deck so that the grandkids don't fall off, how much railing am I going to need? And those kinds of things. So what I'd like to do is you've all got a blueprint for a doghouse. Okay? A doghouse. What we're going to say is, I put it on inch paper. We're going to say 1 inch is equal to 1 yard in real life. So this is the blueprint. And to build this, where there's 1 inch, you'll make that 1 yard long. Okay? So what I'd like you to do now is take your little square tiles. Did everybody get enough to? You got plenty around if you don't have them. Let's stand them up kind of around the edge here like this. And let's just say we're building the fence to go around the doghouse. So go ahead and build your fence. And then I'd like you to tell me, when we go into the store, let's say we're going to go to Cal Ranch, and we're gonna buy some dog fencing, how much are we gonna have to buy? Okay? So,
Bigger than the square.
you what?
These squares are bigger than the lines.
Me?
They are.
Okay. Maybe my master is off just a bit. We'll pretend that there's one per square, right? It's pretty close. It is a little bit bigger, isn't it?